Okay, so you should have done the review yesterday, the review worksheet yesterday, hopefully. Okay, today we're just going to go over it, and then you have your test. So you're going to take your test either today, tomorrow, or Friday. Again, Friday is the last day to do any work. We will be meeting tomorrow, though, so please do check in. Okay. I'll just answer any questions you might have. We'll say goodbye and see if anyone wants to add anything. Maybe we'll do a survey about the course, because I'm sure there's some things you guys want to tell me how much you hate everything about this course. I'm sure, right? Yeah. It was definitely a challenge this year, right? Definitely a challenge this year. Kind of just threw it at us. All right. Anyway, so let's go over this worksheet here. So the first part is just identifying whether something is an acid, base, or salt. And the only difference really, acids, remember, acids give off H plus. That's either definition is give off H plus. And then bases either give off OH minus or accept H plus in solution. All right, and then they do have some specific properties about them. Okay. And then salts are usually neutral. They have they're an ionic solid with a positive ion, a positive cation, negative anion, and then the positive ion is not an H plus, not an H plus, and the negative ion is not an OH minus. Okay, and sometimes actually salts can be acidic or basic, but we're really not going to get into that right now. So basically, acids H plus, bases OH minus, or something that takes on H plus. Okay. Yeah, so that's acid, base, and salt. For pH, POH, H plus, and OH minus, you just need to remember all of those relationships. And even if we weren't in this situation where we're doing, where you can basically look at all your notes while you take a test, I give this information to you anyway. I always say pH plus POH equals 14. Okay. We know that the negative log of the OH minus concentration is the POH, sorry. And then the negative log of the H plus concentration is the pH. If you want to find H plus concentration, there's really two ways to do this. One way is just 10 to the negative pH. If you want to find OH minus concentration, it's 10 to the negative POH. You can also use the Kw. Kw is the concentration of H plus times concentration of OH minus. And these two things will always multiply to give you 1 times 10 to the negative 14. Okay, so for the POH, if you're given pH, I just use this equation here, really easy. 14 minus 2.3, you get 7.7. And then for the H plus, it's just 10 to the negative pH, so this is just 10 to the negative 2.3. And this one is just 10 to the negative 11.7. So that's probably the easiest way to do the first two, 17 and 18. Just subtract this one, your 14 minus 2.3, and then it just obviously switched there. You can see it. Okay, but then if we're given H plus concentration, I tend to like to go actually to OH minus first. So do this one first using this equation here. I find that works the best. If you do like negative log of this, sometimes this number doesn't come out exactly. It's more like a bunch of decimals. So you're rounding already, and you don't round as much. I feel like you round more if you go from H plus to pH than you do from H plus to OH minus. So I usually do these two first, and then go to POH and pH. But up to you, totally up to you how you do it. On the quiz or on the test, the answers, there's like there's like this. If you get like 2.8 or 2.7, just pick the answer that's closest to it. Okay. I didn't give you like 2.8. Like if your answers on the quiz A, B, C, D. I didn't give you like 2.7, 2.8, 2.9. I didn't do that. I did like 2.7, like this was 2.9, right? So I did 2.9 and then I do like 3.5 and 5.7. So they're pretty far apart. So just pick the one that's the closest to it. Okay. If you do it, because there's a little bit of rounding there, and sometimes the rounding can make your answers different. Okay. Just slightly different. Okay. Next, looking at Bronsted-Lowry conjugate acid-base pairs. So here, NH3, if we're going from NH3 to NH4, it takes on an H plus to become NH4 plus, so therefore it's the base. Then H2O goes from H2O to OH minus, therefore it's the acid, it gives up H plus. And remember, acids and bases are always in the reactants, and then conjugate acids, conjugate bases are always in the products. Okay, so then if you look at it backwards, NH4 to NH3 gives up an H plus, therefore it's the acid. OH minus to H2O takes on an H plus, therefore it's the conjugate base. Okay, similar thing for number 22 here. HCl gives up H plus to become Cl minus. That's why it's the acid. H2O takes on that H plus to become H3O. That's why it's the base. And then this is the conjugate acid. This is the conjugate base. Just that order. Okay, next one, 23, 24, 25, and 26. 23, 24, 25, and 26, they all use this equation, the equation that the number of H's times the molarity of the acid times the volume of the acid needs to equal molarity of the base times volume of the base times the number of OH minuses. Okay, and this is for a neutralization reaction, so anything that says neutralize. Yeah. I'm going to do all of them, Princess. Okay. So here, one of the key things is to remember the number of H's. That's what a number of OH minuses. That's what most people forget. So number 23, though, number 23, it's just 1 OH minus and 1 H plus, just 1 and 1. So the molarity of the acid is what we want to know, molarity of acid. The volume of the acid is 125. Now we can convert that to liters. Really, technically, that's what we should do. But if we keep them both in milliliters, it works just fine. So I'm just going to leave it in milliliters. Doesn't really matter. Okay. So molarity of the acid times 125, and then the molarity of the base, which is 0.1, times the volume of the base, which is 54. Okay. And then we're solving for molarity of acid, so we divide by 125. Divide by 125, and we should get this answer. Okay, number 24. Number 24, so the molarity of the acid is 0.05. The volume is 25. The molarity of the base is what we're looking for. And we have 345 milliliters. Okay, and both of these, again, OH and HCl are 1 and 1, so just 1 and 1. Doesn't matter. And then divide by 345. And divide by 345. 0.05 times 25 divided by 345, you should get that. Okay, here comes the tricky ones, number 25 and 26. So here we have KOH, this is 1 OH minus, but here this H2 has 2. There's 2 of them. Okay, so when we do the number of H's, it's 2 times the molarity of the acid, which was what we're looking for. And then the volume of the acid is 125. Okay, and then the molarity of the base is 0.5. The volume of the base is 50. And then number of OH minuses is 1. Okay, so we're solving for molarity of acid here, so we divide by 2 times 125. Divide by 2 times 125. Okay, and we should get 0.1. Let me just make sure in my calculator here. 0.5 times 50 divided by 2 divided by 125, and I got 0.1. So I think the key here is remembering this 2. So Princess, did you remember to get that 2 in there? Because there's 2 H's in this H2SO4. Yeah, so that's the common mistake that most people make. Okay. Because really for every mole of H2SO4, we actually get 2 moles of H plus. Okay. Number 26. What is the molarity of sodium hydroxide? Sodium hydroxide is just NaOH, so it has 1 OH minus. If 200 milliliters is neutralized by 5 milliliters of H3PO4, so this one has 3. It's actually going to be 3 times the molarity of the acid. So 3 times 1 times the volume of the acid, which is 5. That's equal to the molarity of the bases, which we're looking for, times 200 milliliters, and then there's only 1 OH minus. Okay, so it's 3 times 1 times 5, and then you're going to divide both sides by 200. Okay, so 3 times 5 is 15 divided by 200. You should get that, 0.075. So that help, Princess? Okay, next one. Number 27. Explain chemical equilibrium. Doesn't mean products and reactants are equal. Well, at equilibrium, it doesn't necessarily mean that products and reactants are equal to one another. It just means that the rate at which products turn to reactants, reactants turn to products, they're going back and forth. They go back and forth at the same rate. They're going back and forth at the same rate. Okay, so the rate of the forward and backwards reaction are equal. It's not necessarily that the concentrations are equal. Okay. 28. So this is Le Chatelier's principle here, just some practice on Le Chatelier. So if we add Cl2, we have too much Cl2 on this side, it's going to shift to the left. It overflows to the other side. Therefore, these are going to go down, and this one's going to go up. But K stays constant. K stays constant for any change in concentration. Okay. Now, if we increase pressure, it's going to shift to the side with the least moles of gas. This side only has 1 mole of gas, only 1 mole of gas, so it's going to shift left. Therefore, these are going to go down. This is going to go up. And then K is also going to change. So if the products are going down, remember K is products over reactants. So if products are going down, then that means K goes down. Okay. Addition of heat. So this is an endothermic reaction. Endothermic means that heat is going into the reactant side. So I can treat it like a reactant. So if I increase the temperature, I add heat, I increase the temperature, that means that this goes up. So it's going to shift away from that. It's going to shift right. That means PCl5 is going to go down, and these are going to go up. Okay, and then that means K goes up as well because products go up. You're going to have more products. That's more on the numerator side. You get a larger K. Okay. Then last one. Removal of PCl3. So if you remove some of this, we create a hole. Remember, if we create a hole, we got to fill that hole. So we got to shift towards the hole. So that means these are going to go up, and this is going to go down. Okay, but remember, removing or changing concentration does not change the K. So K stays constant there. Okay, that's it for Le Chatelier. There is another practice problem here, but it's the same kind of thing, so I'm not going to go over that one. Kw, again, is the autoionization constant. It's always the same. It's always this number, 1 times 10 to the negative 14. It never changes. These two will always multiply to give you this. So if you have one of them, you can find the other. Okay, next one. So here, we really didn't do too much of this. I didn't even put this question on the test, but whatevers. It's fine to go over it real quick. If we have an acid and base, so this is the acid, this is the base, they're going to react to form water, pretty much always water and a salt. So this is a salt, and as we know, H2O is water, right? So it always forms water and a salt. And what you're doing is you're taking the H and the OH minus, forming water. And then the two left over, so you're going to have the Na left over and the SO4. The Na is a positive 1. SO4 is a minus 2. So you have Na2, SO4. So because remember, Na plus 1, SO4 is a minus 2. So these charges need to cancel. So you need 2 of these. So Na2, SO4. That's where that comes from. Same thing here, H3PO4, CaOH2. H and OH come together to give you H2O. And then you're going to Ca and PO4. Ca is a 2 plus. PO4 is a 3 minus. These come in multiple of 6. So you're going to need 3 of these and 2 of these. That means this is negative 6 and positive 6. They cancel each other out. Okay, so yeah, products are always salt and water of acid-base reactions. An indicator is any substance that changes color due to pH change. Okay, they can be used to determine the pH of a substance, or they can also be used as an endpoint in a titration to find the concentration of an unknown substance. All right, and then when something is at equilibrium, the rates of the forward and reverse reaction are the same; they're equal. Okay, A titration is a process where you use a known concentration of either acid or base to find the concentration of unknown acid or base. If you know the concentration of one, you don't know the concentration of the other, you can find the concentration of the other. Okay? And the equivalence point of titration is when the moles of acid equal moles of base. That is really the end of a titration. Okay, that's when the titration is over, usually. Okay, and that is it for the review. Are there any specific questions on the review? No, I think that explains most of it. I'll post this video